Hi, my name is César Leblanc, and I'm here to introduce GeoPl ntNet, a web application designed to make essential biodiversity variables accessible to everyone. Understanding biodiversity dynamics is critical. We need tools to detect species range shifts, monitor ecosystem degradation, and guide conservation decisions. GeoPl ntNet addresses all three. Our pipeline combines multiple AI models. First, we map species distributions using a multimodal convolutional neural network. Then, we infer biodiversity indicators, and we use a large language model to identify habitat types from the assemblages. We use the GeoPl dataset, 5 million citizen observations, 90,000 vegetation plots, and 20 years of environmental and satellite data. Our species distribution model is a multimodal ensemble of 3 ResNet-like encoders, 1 per modality. Conformal prediction is used to prioritize minimizing false negatives, and no coordinates are used, ensuring the model reflects habitat suitability. We then apply PlantBERT, a domain-specific language model trained to classify species assemblages into habitat types. This model uses no environmental data, just species presence, making it robust to sampling bias and suitable for generalization across regions. Here are some screenshots of the results. Interactive maps for over 10,000 plant species on the top, 7 biodiversity indicators in the middle, and over 200 habitat types on the bottom. All maps are available for the whole of Europe down to a 50 by 50 meter scale. GeoPl ntNet supports many use cases, from biodiversity monitoring to conservation planning. Its modular design allows users to navigate species, indicators, or habitats independently. Everything is open access. The web app is live at geo.plantnet.org, and both the models and datasets are available on GitHub. Now, let's do a quick live tour on the GeoPl ntNet platform. Let's start by selecting a country, let's say France. On the left, you will see a global report, giving you some interesting insights on the biodiversity of the country. You will see, for example, the number of predicted endangered species, but also the most commonly predicted species, and a lot of other biodiversity indicators. Let's go to the species module. Here, you will see a list of species, from the most commonly predicted to the least commonly predicted. You can also check for specific species. By clicking on it, you will see everywhere the model predicts these species. Since the resolution of the model is 50 by 50 meters, you can zoom in. Let's go to the Habitats module and let's select a Mediterranean coastal habitat, such as N14. By clicking on it, you again see everywhere the model predicts this habitat. Let's now go to the Indicators module and let's select a biodiversity indicator such as species richness. Let's zoom out a bit and try to find a biodiversity hotspot. Here we can see a clear one. Let's zoom in a bit on it and remove the opacity of the model. Let's activate the OpenStreetMap layer. We can see that we are in a nature reserve, which makes sense. Let's draw a polygon there. We can see that our model predicts one species classified as endangered there. Let's click on it. And indeed, we can see that our model predicts this species everywhere in the nature reserve. GeoPl ntNet also allows for looking a specific city. Let's go to the south of France in a small village. Let's say this village wants to expand and doesn't know if it should expand on the north or on the south. Let's draw first a polygon on the north, here. We can see that our model predicts one species classified as vulnerable there. Indeed, it looks like this species is really present on the north of the village. Let's draw a second polygon here. This time, no species classified as endangered or vulnerable. Maybe it's a better idea if the village expands south. Thank you for listening to me, and please give a try to GeoPl ntNet at geo.plantnet.org. Thank you.